We have created our person page and person widget content types, and we have also created some content items from the admin. So far so good. And although we have also defined a lot of things in code, we haven't really yet interacted with the content items from code yet. Well, in the driver and in the handler, we have interacted with the content parts a bit, but well, let's do something with the whole content items. Because of course, don't be mistaken, everything you can do from the admin in Orchard, of course, you can do from code. Since, well, there are just services behind everything, the UI is using the services as well, and you can also use all of these services from your modules. So it's also possible to query content items, update, delete content items from code, whatever you imagine. It's a kind of data storage where you get the full CRUD spectrum there. Now, what we'll do is that we'll query content items. We'll fetch them from the database. And although there is a lot more you can do with the content items, for more details, you can check out, well, first of all, of course, the Orchard source, and for examples, and also the train demo module where we have a lot of examples of this as well. But just to give you a bit of a taste, let's create a controller where we are fetching person pages. So I will now create a controller called, let's call it person controller. And again, I will of course use the snippets, person controller, great. We have everything here. And let's create again a simple method here that will just return a string, so we know that something happens, but we don't need the full HTML fanciness. So let's create a string returning async action, because we are now talking about the database, or talking to the database via Orchard services, which is I/O, which is of course asynchronous. So all of this should be async. So let's call it list, because we'll list person pages. And now let's fetch those person pages. How to do that? That's a great question. How we are querying content items in the current setup, or out of the box, is via SQL, of course. And remember that I've shown you the database a bit and the index tables, which we'll take a look at again in a minute. That's how you can run ordinary SQL queries and still fetch content item documents from the database. And again, storage and querying is not tightly interconnected. You can store your content items in an SQL database and query them from a Lucene index. Or you can store your content items in flat files and query them via SQL, or whatever you can imagine. Since we are storing the content items in the database now, and we will query them in the database, we need to access the database. And how we access the database is via something called an ISession. Again, I'm using our dependency injector here. And ISession is actually not the ASP.NET Core session, but a YesSQL session. This is a database session, an SQL session. This pretty much represents a database connection. Much more, but for now you can think about it like that. And what's available in this session? Well, let's check it out. And what's available in this session is, well, for example, a method to query it. when you are querying a YesSQL session, YesSQL being the document DB over SQL engine or kind of ORM, you can think about it, abstraction, library. How you query something from that session, ISession is always with such a query method. And well, a common way to do that, there are of course a lot more overloads and a lot more methods. But a common way to do that is by opening a query for an index, because you commonly don't just want to list all the documents in the database. You want to list just a specific subset of them. So you kind of always start with an index table. And the index table what we'll use will be the content item index table that we have seen before. So this is a built-in index table in Orchard. You can run SQL queries on this index table to filter on various things, like filter on the content type of the specific items. So, for example, we can use this to list all the person pages. And this is built in, nothing to do. What will happen is that although we'll query on the index table, automatically the corresponding documents will be joined in. So we'll query on this index table, filtering for the content type person page, but all the corresponding person page documents will be joined in, and we'll be able to inspect them. So let's start. The query should always start for the document. Start with the document, or not always, but in this case, in such a notation, should start with the type of the document, because the document table can contain any documents. We are not querying content items, but content items are just one kind of document. You can actually store other kind of documents. You can pretty much serialize other kind of objects into the document table and query them in a similar way without them being content items. There are plenty of cases that in Orchard too. But for now, we are querying content items, and we are querying the content item index table, or content item index. And then we can specify what to filter on. So here's the predicates that we can write. So we can, for example, filter on the content type here. So let's filter on person pages. All right, and now what? Well, first of all, let me do a bit of formatting here. Now we can do further things. We can do such scalar operations like counting. We can do listing right away, so that retrieves all the matching items. Ordering is also available, and of course paging with skip and take, just as in LinkU, is available as well, and other similar LinkU like methods are also available. So for now, let's just list all these items. And this is async, so we'll need to await it, and let's also save everything out to the variable. So now we have our person page objects here, and this will be actually a content item object. There's one thing necessary to make this very good, and that is that we need to initialize these items. Remember that what we have done here is, in the end, an SQL query. Nothing more fancy here. This is just an SQL query. We query the table, we joined in another table, and we kind of deserialize rows into objects. But nothing else happened. For example, if there are handlers for these items, and by chance there is actually a handler for these content items, then those handlers didn't run because there was nothing to run it. This is an SQL query. The SQL query doesn't run our handlers. So what we need to do is that we have to specifically run our handlers on all of these content items. And that's or not just handlers, but rather everything, including handlers. And that method that initializes our content items is called loadAsync on the service called IContentManager. So another service that we are learning right now. So it is called IContentManager. All right, let's take a quick look at this. Here we have methods for managing content items. For example, you can also create new content items here. New async is kind of like the new operator. You create a new content item, but it's not persisted yet. Create async is what actually persists the content item, etc., etc., etc. You can also fetch individual content items with these methods here. And you see that we also have versioning here. Same thing that we have seen before. And there are various other methods here. What we are more interested in now is loadAsync. So let's actually run it. I will do it in a simple way and just write for each. Yeah, it's actually a content item. Oops, I made a typo here. Content item and person pages, or we could rather call it person page. And let's run ContentManager.loadAsync on all of these person pages. And this is async, so we have to await it. Potentially we could also run these in parallel, although I'm not entirely sure that this is guaranteed to be thread safe. The handler implementation and everything is definitely don't. Or these definitely aren't guaranteed to be thread safe. So better to run all of these actually in serially. All right. And now that we have our person pages initialized, let's display some data out of them. So let's return a string here that contains all the person names. All right, so we will just concatenate all of the people's names here. And well, how we can do that is that we can select something from the person pages. Well, what should we select? We can name this again person page, and then what we have here is a content item object. And remember that we looked into what's in this content item object during the theme development part. Now, we could actually do something like that. We could access content part data in the document too, which would be the storage format. What's a bit more convenient is that we can kind of cast these content items to our person part, which basically means that retrieve this part from the content item. And our person part, of course, has the name property. So now we have all the person pages here, everything listed. So let's run the application and let's see whether this actually works. We'll need to access this controller here, so person controller /list. Usual stuff. All right, person controller and list John Doe. That's good because we actually have a single person page. So yeah, not much of a surprise. Let's actually create another one so we can see whether it actually nicely works. And spoiler alert, we'll also need it in a minute. So let's create a person page again, and let's call it Jane Doe, and birth date, let's do something else. Yeah, so this is an actual living person, not a vampire from the 1300s. And let's publish. So now we have two person content items, Jane Doe and John Doe. Jane Doe like this from 1990, and John Doe, oh, it's from 2020. John Doe can be from 1950s. I mean 1950. Oops. Okay, 1950s, because we'll need a bit of a distinction here in a minute. All right, and it works. So that's great. We can do some further filtering here if we would like to have. We can filter on just published content items. Well, our person pages are not draftable, so that doesn't really matter. But still, for other content items, we could do that. We could also order by the last modification date. We can do paging, etc., etc., etc. But let's do something with our own content part now next, and let's filter on the age of people. So let's say that we want people 40-year-old or younger. So there is one 40-year-old or younger person and one older one. So this will be a nice test. Now, how can we do that? Now, of course, this person pages here is an IEnumerable. We can just write link queries on this and do the filtering, and that would work now because we have two person pages. If we would have 200 million person pages where we would filter out like 90% of those, then that would be quite painful, quite slow. We would fetch all the data from the database and we would filter in memory. Of course, that's not what we want to do, but rather we want to filter in the database, since that's what SQL databases are very good at. And of course, we will do the same thing. There is this content item index table. We can filter on it. So we will write our own index table and we will filter on it. So let's do that. We'll now create a filter class and a filter table that allows us to filter on the birth date of people. And how that will work is that we'll create an index class and the corresponding index provider. Where we commonly put these things is in the indexes folder, and if you are saying that it's not indexes but indices, then you are very well right, but still. Let's call this person part index. And the good news is that you don't have to write all the boilerplate here, but you can use the map index snippet, which will generate it for you. It's called map index because this is an index that maps, in this case, content items with person part to a person part index. This is map as in map and reuse. Yes, SQL operates with this terminology. And well, first we need an index class, which will be kind of the ORM, so the object relational mapping model for the rows in the table. And then we will need to create the table. That we'll do from a migration class. And we also need this index provider. This index provider will pretty much take the documents that are being saved, in this case content items, and produce corresponding index records, index objects here, which in the end will be stored as records, as rows in the index table. So the index provider is doing that. We see that this index provider is an index provider for content item object, and we can leave everything else on default. And here we can write the logic that will actually create the index records. This is just standard C#, so don't be intimidated by all this terminology. You can write whatever logic you want here. What we'll do now is that our index provider will create an index record for every person page content item. But that's not necessarily what you need or what you want. We could, in this block, we could write logic to say that we only create an index record for published content items. So if your content type is draftable, then you don't want to create an index record for a draft version, just when it is published. And secondly, do note that you are already kind of filtering when creating these records. So you could also have an index provider that only creates records for people that are older than 18, and that would mean that you are here in this index provider. You have logic that determines that, okay, for this person, based on the person parts data, I won't create or I will create an index record. And then later when you query those items and you query on that index record, you will kind of already get a pre-filtered list, because only those items have an index record to begin with that you actually want to access. Now with the age, this is a bit of an issue, because the age has the curious property of changing. So that would only work if you are periodically updating your person page content items, but you get the idea. But here we won't do anything too fancy. We will just create an index record for every content item, every person page content item. So the only criteria will be that it should be, well, actually, not person page content items, but content items having person part. So including widgets, for example. Let's first retrieve the person part, which again can happen with the same as method that we have seen previously. So person part here. And then if person part is null, that means that the content item doesn't have a person part. Then we don't want to do anything. And if it does have a person part, then we will return a person index. So let's make it in a ternary, with a ternary operator to make it nice and compact. And let's say that if person part is null, then let's return null. And if person part is not null, then let's return a new person part index. Person index. I mistyped it. It should be person part. So let me rename the whole thing. Yeah, it should be person part here. And this should be person part index provider as well. The file name is correct. All right, but we don't really have anything in the index class yet, so let's fix it. In the index class, we can have a property for the birth date, since that's what we want to filter on. And again, not birth date type, but datetime, and again it should be nullable. Oops. And again, it should be birth date UTC in UTC. And this will be an index for person parts based on the birth date. So you can actually also have different indices for the same content item. You can have multiple such index providers that will all create index records for the same content item. So you can already kind of cluster or shard your indices like this. Secondly, you can also have bigger indices, index records that contain multiple pieces of data that you want to filter on. Both can be viable. It depends on the database engine you are using and the amount of data that you have, whether it makes sense to complicate it or not. But this is a simple case. We will just have birth date UTC. And commonly, we also add a property for the content item ID corresponding to this index, because a content item is just kind of a document. The ID of the content item is a property on the document. If you want to quickly get from the index to the content item, so not the currently joined document, which is corresponding to the content item, but to the let's say to the actual or to the current content item quickly, then you need this ID. Because we are now in SQL. What we are doing now is that we are joining a document from a document table with a row from the index table. That document might not be the latest version of that content item. But if you have the content item ID, you can quickly get everything else for that content item. So now we have the index here. And the final thing is that we have to create a table. So let's go back to our migrations class. And here we haven't actually created a table yet. That's what we'll do. And again, we'll need to write an update method. But again, we will go back and put everything back into the create method too. Oh, and one thing I actually forgot it. You have to register your index provider in the startup class as well. So index providers are actually singletons. Oops, add singleton. Yep, and they are index providers. Yeah, and we need our person part index provider. All right, oops. So back to our migration class, and let's write our table creation logic for the index here, and we have a create map index snippet here as well. So again, you don't have to type in everything. So in the map index, we need a name which in this case should be the name of the index class, which is person part index. And then we will we will need to actually define the table. So now we are back into SQL. We need to create columns. And that's what we'll actually do. First, we'll need to create a column for the content item index. And we have again a bit of configuration options here. Well, first of all, we need to specify the name of the column, and then we have to configure the column too. Well, the name of the column, again, we can use the name of trick that we have used before. So that will be personPartIndex.ContentItemID. And there is one thing necessary for this column. Well, it's not really necessary, but it's a good practice, is to restrict its length. So remember that these index tables are about querying, and querying is largely about performance. If you keep your columns small, then querying can be faster because the SQL indices on them can be smaller. So it's nice to actually restrict the length of this column where you are storing content item IDs, because we know that content item IDs can't be longer than 26 characters. Because 26 characters ought to be enough for everyone. That's something Bill Gates said, no? Or something like that. Now, we also need to add, I didn't actually want to put this here, but we also need to add a column for the birth date, of course. So that should be a date time column. Yep, and the date time column again can use the name of trick. Wow. So again, the date time column can use the name of trick with personPartIndex.birthdate UTC. And well, we could also do some kind of configuration here, but for this, it's not really necessary. All right, now what we actually created here was an index table. We didn't add database indices here. Database indices can also be added, I mean SQL indices. Database indices can also be added with an alter table or from an alter table command like this. So if we want to say that, well, this table will have millions of rows, we will always query on birth date, then you can create an SQL index on it to make it faster. And there is a simplified way of doing this directly from Orchard, from migrations, like this. You can specify the name of the table, which is, again, personPartIndex, but luckily the snippet does most of the things for us. And then you can also specify the column to index on here. So this gets a bit long, so let me format it. You can only create an index from the alter table column, so that's not possible from the create map index table, table one. So you always have to do this in pairs. But in any case, now we created a table that contains these two columns, and we'll be able to query on them from our controller via ISession. And secondly, we also created an SQL index on birthdate UTC, so the lookup is faster. Now, currently we have 2 content items, or 3, so that's not exactly a demanding application, but, well, this is food for thought. And of course, we can now copy the whole thing back up into the create method, and don't forget to update the version number to 3 as well. So you see that now we do plenty of things in this create method. So it's actually much nicer to just run it once instead of having all these update steps. Although right now this still wouldn't matter much because we are just adding everything. There's no wasteful work being done. It's just a tiny bit more complex to run all these update steps instead of running the single create method when this module is newly deployed. So, so far so good. We are not yet ready because there is a missing semicolon here. Oh, and by the way, while we are at it, let's also do some querying here. And how you can further filter with other index tables is with this with method. So again, we can select an index, which in this case will be person part index. We don't need to select the document type because that's already content item. And then we can, I didn't want that, and then we can do something like, here's the birth date, let's select all the people who are 40 or younger, because that will be just one item. And we are almost there, but we actually also need some way of retrieving the current date, right? Because yeah, we need to calculate the age of these people from the current date. And for that, we need a clock. And of course, there is datetime.utc now, but that's again not really testable. So in Orchard, there is a testable thing for that called iClock. Yep, and iClock, well, was it the right iClock? Yeah, it was. And iClock is a wraparound the system clock, but it's an injected dependency, so you can swap it out. The class remains testable. No, you are not adding hidden dependencies. So now we can actually calculate the threshold here. And the threshold can be, well, again, computed from UTC because the birthdays are also stored in UTC, and something like add years minus 40. And now here we can say that, okay, we are only retrieving people whose birthday is larger or smaller than the threshold. Let's compute the bigger one. So we are retrieving people younger than 40. And that's it. Let's run the application and let's see whether we are done or maybe there is some issue. And in the meantime, once the application starts, we will also take a look at the database. All right, the application is starting, and I refreshed this person page list, person list, but there is nothing really here. Why is that? And that's something that you have to keep in mind. We now created a new index table. The index table is only populated when a person page content item is updated or created. But that didn't happen, so there are actually no index records in that table. So we have to do something. We actually have to update all of these content items. So I will now go there and do exactly that. Of course, if you have an existing application and if you have many content items, you don't need to do this by hand. I will do this by hand now, but you can also do this update programmatically by fetching the items like we have done by ISession. All right, and let's also publish this one, and let's see what happens now. There is still nothing. Well, let's see whether the database is updated. So let's take a look at the database and let's refresh this. I will close the database and reopen it again. And now we should be able to see person part index, so that's good. That table was created. As you can see, we have, well, first of all, we have an ID and document ID column that was automatically added for us. And we have the content item ID and birth date UTC that we specified. So let's also browse the table, and we see that there is nothing really here. And why is that? Because I didn't quite finish the index provider here. So let's actually do that. Of course, that is necessary. The content item ID should be the content item ID, and the birth date should be the birth date as we can retrieve from the person part index. So now let's go back to the admin and let's refresh these again. We'll need to update the content items again. My note about the index is missing is still valid. And by the way, you may notice that in the controller now we are filtering here on person page, and now we are filtering on person part index, or we are retrieving content items with person part index. So maybe this first filtering is now redundant. It actually kind of is. Well, we do have the person widget, so this excludes person widgets. But actually, if all the items you want to retrieve have a content part, or rather you want to retrieve all items with a specific content part, regardless of their content type, then you can get rid of such a filtering. You can just filter on your own index. All right, so back to the admin, and let's refresh Jane Doe. Jane Doe should be listed, and let's refresh John Doe. John Doe shouldn't be listed here, and that's actually what happens. So the filtering works, the index table, index records, index provider, everything works, and all the querying via ISession also works. Now, of course, there's still a lot more on managing content items from code. There is a lot more to querying. You can also then build the display of content items. You can also create content items from code. You can also delete content items from code. You can also modify content items via setting properties on their parts. There's a lot more to it, but well, we don't have time for everything, and the training demo module has a lot of examples related to these too.